All right, hello, Cray and Marcus. Hopefully you're watching this. This is Trig semester review. This is the first part of it. They have decided to go front to back instead of back to front, so we're starting with number 1. This is chapter 5. This is all exponents, so you need to remember how to cancel exponents and do all of the things, all right? So here's the first problem. I have a square root on the top and a square root on the bottom.
Erase it.
And what I can do, I can't erase it, but what I can do is I can combine that all under one square root. And then I can reduce all of the stuff underneath, right? Like all of the C's I can put together, all of the D's I can put together, all of the numbers I can put together, okay? So you can put that all under one roof. And then we're going to reduce what we can. So starting with the numbers. 8 and 4. 8 and 4 can become 2 and 1. So I'm just going to put 2 on the top. We don't necessarily need the 1 on the bottom. Okay, C's, I have 2 on top and 12 on bottom.
10 on bottom.
So 10 on bottom. I'm going to start making a new list, okay? So 2 is on top, right? You said we have 10 C's on the bottom if I cancel those, okay?
4 D's on
D
top.
on the top is 4. Okay, now I can't leave it like that because I have to take anything out of the square root that can be undone, right? Okay? The square root of 2
Is the square root of 2.
Like why?
It's the square root.
the square root of 2. I'm gonna put it like as the square root of 2. What about d to the 4th power? What's the square root of d to the 4th power?
Squared.
D squared, but it comes out, right? The square root of d to the 4th power is saying what do you take times itself to get d to the 4th, right? What do you take times itself?
Hey, can you leave it on the end?
Why the heck is it in the?
You can leave it on the end, but then
Just
it
make
looks
sure
like
it
it's
doesn't-
underneath of the square root. Yeah.
Mine doesn't.
Okay.
And
then
C5.
c to the 10th power. It's like
C
what
to
do you take
5.
times itself to get c10?
Wait, why are you doing that?
C5. I'm taking it out of the square root because you can take the square root of d to the 4th power.
So you
And you
just,
can take the square root of c to the 5th.
exponents divide by 2.
Yes, exponents. That's a good thing to write down. Exponents. When you're taking the square root of an exponent equals divide by 2. I don't know how you want to write that, but that's how it makes sense to me. So if you are taking exponents like d to the 4th power or c to the 10th power, you're dividing it by 2. You are not taking like the square root of the 4 or the square root of the 10, right? You're dividing the exponents by 2. But when you take the square root of 2, you are taking the square root of 2 because that's just a number, right? Okay?
Yeah.
Yep, this is our final answer. That's as far broken down as we can get. Yeah?
Yeah.
Okay. I should maybe add, I don't know if I do this. Can I do this real quick? No. What happens if we had like the square root of c to the 7th power? What happens if that happens? Then you have an
You hang
odd
one
power,
off.
right? Okay, so I can take the square root of c to the 6th power, right? And then I would leave 1 off, like c to the 1st power, because together those combined would become 7, correct?
Yep.
Okay, what is the square root of c to the 6th power?
C to the 3.
C to the 3rd is going to come out. And what about the c there? He's left underneath, okay? So if you have an odd power that doesn't divide by 2, you're going to leave 1 inside, right? Does that make sense? Okay? So just FYI, if we have an odd power, that's kind of how that works, right?
Just don't do an odd power. How about?
Wait.
Sure. I don't remember if I do or not, so I want you to be prepared.
Okay, keep going.
Okay? Good? All right, moving on.
I don't like that.
Yeah. Okay, here we go. Rationalize. What does rationalize mean?
Oh, take the square root out of the bottom.
We don't like square roots on the bottom. Okay, so this is 6 plus the square root of 3. How do I get rid of 6 plus the square root of 3?
Multiply.
I multiply
The
by
reciprocal.
the
So conjunction.
conjugate. I want to do the conjugate, which is 6 minus the square root of 3. 6 minus the square root of 3. And I'm multiplying, okay? And now the reason why I'm multiplying, because this, what's 6 minus the square root of 3 over 6 minus the square root of 3?
Huh?
What is that reduced to? 1. So I'm taking this thing times 1. So I'm not changing it. I'm just changing what it looks like, right? I'm not changing its value, okay? So then what do we do from here?
Do it.
We FOIL. Yeah, we FOIL. So I take 1 times 6. 6. 1 times negative square root of 3. Minus square root of 3. Okay? Then I start with the 5. What is the square root of 5 times 6? 6 square roots of 5. You can't multiply them together because one's on the inside, one's on the outside. What is the square root of 5 times negative square root of 3? Negative square root of 15. Yep, I can multiply the insides together because they're both underneath. Okay?
And then
All right, that top. Let's just look at that top real quick. Can we reduce anything or put anything together in the top?
No.
No. They have all different bases, so we cannot put anything together.
Opposite.
Where?
It's
Square root of
the
3 and square root of 5, we can't put those together.
15.
Huh? You.
The square root of 3 and the square root of
I thought
15?
she said what is
No, we can't put them together. When you're
Oh,
adding and subtracting, they have to be
Bottom
exactly
is
the same base.
36.
You can multiply them if they're different bases, so you can't add and subtract, okay?
The bottom
All right, the bottom,
36.
6 times 6 is 36, okay? What's 6 times negative square root of 3?
6 minus 6.
Minus 6 square roots of 3, okay? Then you do positive 6 square roots of 3 is the inside pieces. And then what's the square root of 3 times negative square root of 3?
Nothing.
No.
3. Negative square root of 9.
Negative square root of 9, which is just
3.
3, right? The square root of 3 times the square root of 3 is 3. The square root of 7 times the square root of 7 is 7, right? Anytime you take a square root of something times itself, it just pops out of the square root, right? Okay? So this is what should happen. This should cancel out. If it doesn't, then we still have a square root on the bottom, which did nothing, right? That's what we're trying to, avoid. That's what we're trying to get rid of. So on the bottom, the top stays the same. We can't do anything with that. Like he stays like this. Okay, the bottom becomes 33. That's it.
That's the answer.
Yes, we cannot reduce anything. If everything was divisible by 3, then we could reduce it all or whatever, but not everything's divided by 3. What? Not under the square root. So the numbers on the outside would have to be divisible by 3. Do you see that? Okay, you can't touch any of the numbers on the inside. All right? Okay, good? All right, number 3, simplify without using a calculator. That means do not give me any decimals, because how easy would it be to put this in the calculator? We don't want any decimals. You can only add and subtract. I just got done telling Kelsey this. You can only add and subtract if they are the same base. I have the square root of 3 and the square root of 48, so we cannot put them together. But
If we take it times
48 breaks down, and I'm guessing this is a 3 right here that's left under, right? What's 48 divided by 3? 16. 16.
I mean, I
Okay.
don't know it, but
So 48 is reduced by...
4 square root of 3.
Yeah, so the square root of 16 is 4, and the square root of 3 stays the square root of 3, right? So now instead of the square root of 48, we're doing 4 square roots of 3. Does that make sense?
Yep.
So we have 11 square roots of 3 minus 4 square roots of 3, which is 7 square roots of 3. It still has square roots of 3 on it. Think of this as 11x minus 4x. You're not subtracting the x off, right? It's still 7x. It still has an x on the end, right? Okay. So 7 square roots of 3. Happy with that? Yeah. Okay. All right. More exponent-y stuff.
Okay, so we have to multiply. We have to take 2 squared, and then
How do
Hold
you
on.
know when you need to take it and foil the 2 or just distribute?
So this one doesn't have a plus sign.
Oh, okay.
So I can just distribute the 2 through. But you could, so if it helps, don't write this down, but if it helps, what it means to square something is to take it times itself. 2x cubed y to the negative third and 2x cubed y to the negative third, right? So I would take 2 times 2, and I would take and combine the x's, that would be 6 of them. And I would combine the y's, that would be negative 6 of them. Does that make sense? Yeah? Okay, so that's what it means to square something, right?
When you take it through, it's or if it was any other number, it wouldn't be that number times 2. It would be that number times itself 2 times, right?
For exponents?
Yeah.
No, it's that number times 2. So we would, this one would be 2 squared. This would be x cubed squared and y to the negative third squared. So let's just do that top part. So don't forget to square the 2. Squaring the 2 would make it
I'm already done with
4. Okay? It would be x to the 6th and y to the negative 6th. Okay? On the bottom, we'll just leave him like this, negative 3, and y to the 5th. Okay, before we put stuff together, this is testing your knowledge of whether you know x squared times x cubed, which they do this on the ACT a lot, or x squared cubed. They do this concept a lot. Which one do you add? Which one do you multiply? The top one you add is x to the 5th power. The bottom one is x to the 6th power. You're multiplying the exponent. So when we distribute that 2 through, we were multiplying, right? We're not adding, we're multiplying. Okay? But here in a second, we're going to be adding exponents, right? Yep. Are we ready? Okay. All right. Let's do numbers first. 4 and 6.
2/3.
2 and 3. 2 and 3. Okay, we have negative exponents.
Move them to the bottom.
We move them opposite, right? Okay, so this x to the third can come up here to be x to the third. This y to the sixth becomes y to the sixth, positive 6 on the bottom, right? So now,
It literally, how? How can you do that?
Why?
You just flip them.
you flip them and they become positive. So like x squared is the same thing as 1 over x to the negative 2, right? Like that's how they work. If you go top and bottom, it becomes a negative exponent. Okay.
X to the ninth on top.
Okay, so I'm gonna write out all my stuff. So I have 2x to the sixth, x to the third, right? Okay. If you don't want to write the step out, you don't need to. I have 3y to the fifth, y to the sixth. I'm just writing everything out. Okay. So now we are adding the exponents. We're not multiplying them. So 2x to the sixth, it's not 18, or to x to the ninth, excuse me, 9, not 18, right? The bottom is 3y to the 11th. Is there anything else I can do to simplify? No, that is all. Okay?
Yep.
All right?
Yep.
If you don't want to write out all the steps, you don't have to. If that middle step you can skip, I don't care. Okay? All right, now we're getting into logs. So this is an exponential function. exponential. This is an exponential function. We like these. Give us more of these because all you're doing is writing it as a log function. Okay, it's log with a base of 3 of y equals 2k. That's all.
Whoa, hold down, dog.
Okay,
Wait.
that's all you're doing.
Whoa, stop.
Can you do like maybe an example the other way around?
I didn't
Sure.
even.
I didn't
So I'm
even
going to
do that.
say 2 to the third power equals 8 would be log base 2 of 8 equals 3. That's the order that they go in. Okay?
Whoa, I'm
The first number is in the same spot. The second two numbers switch places with each other.
Who has my calculator?
You're bold.
Call me to mine. What batteries?
Did I?
Last
It's
time.
back a little. Did you take it?
Nope.
Back? Oh, it's probably up here in that basket. Okay, good?
No.
How much are we gonna do today? Can we?
I don't know. We're going to try to do as much as we can. 15 if we can, right? How long will a table take to double an investment of blah, 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 blah? And these are the key words. Compounded continuously.
So when we get more.
Do you know what formula we use for compounding
PERT or
continuously? PERT, yeah. So A equals P-E to the R-T power. Do you know what each of those variables represents?
Yeah.
E is just constant.
E is just your
after-
number, right?
P is
The principal.
principal. E is the thing, right? And
R is rate and T is time, okay? So how long will it take to circle the word double an investment of 300? Okay, so where does the 300 go?
300 is the after.
300 is the P. That's what I'm starting with, okay? So if they're saying double, they're really just saying 600, right?
Yep.
They don't tell us that, but they say double, so that means 600. E to the R.
Is 0.05.
R is 0.05 because we make that a decimal. And then what are we solving for?
T.
T. How long, right? How long is what we're solving for? T. What?
What's E?
E is just the E number in your calculator,
Oh my
right?
God, I'm so stupid.
Okay? All right, so what should we do first? We have to unwind this to get T by itself. Okay, divide by 300, which of course should be 2, right? Okay, so 2 equals E to the 0.05 T. Okay, now T is stuck up there and we want him down, so we have to get rid of E somehow. What gets rid of E?
ln.
ln is his inverse.
Do we have to ln
Okay.
both sides?
You ln both sides. If you do it to one side, you have to do it to the other. Okay, so the magical thing is ln and E
Cancel out.
cancel out. So right now I have ln of 2 equals 0.05 t, and it like comes down, right? Okay, and then how do I get t by itself?
You divide by 0.5.
Divide by 0.05. Divide by 0.05. You have an ln button on your calculator.
Slow down. You're going
Yeah,
too
can
fast.
I will.
0.05.
No, 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 no.
Why?
LN2.
So sorry.
Okay, your calculator might open up a parentheses. You need to make sure you close it before you do divide.
13.7.
13.8.
9.
Yes,
13.9.
13.9. What?
Years.
Years, because it's yearly. It's like an annual thing.
If I change the T to
Okay.
an X.
Does that
that's
seem
fine.
like a reasonable amount? 13.9 years. Yes.
I'm changing the T variable, because I don't like that.
You go for it.
Have a different one?
What?
Like
No.
the one where we had like 4 different.
No. It will for this problem it will be compounded continuously. Yep. Okay.
Do I have it?
I will have a half-life one on there, but we're gonna do that one next. Okay, those are the only two that I'm gonna do. Okay? Are we ready to move on? Was that okay?
Yeah.
If you have questions, keep me here. Okay. All right, half-life. There's an equation for half-life, and it was A equals P times 0.5 to the,
Half. Oh, it's.
I'm gonna say T over, what do they call it, H or K? H. We'll call it H for half-life. I think it was K, but we'll call it H for half-life. Okay? All right. Not every chemical reduces in half at the same rate, right? Like carbon 14 is 5730 years, right? 5,730 years. Here we're talking about radium. So its half-life is, it splits in half after 1,590 years. That's what your H is going to be. H is 1590. They have to tell you that information. How long? What does that tell you?
Time.
We are solving for time. I'm going to put question mark on time. That's what we're solving for. Will it take for 10 grams, which is
P.
P. That's the starting amount.
So 1.
To decay to
10.
1 gram. That's the after. Okay? How long? There we go. All right, so let's plop stuff in. So A is 1, P is 10, 0.05, or 0.5, not 0.5. To the T over 1590. Okay, everybody stop and watch. Because I had a lot of you do this, and this is illegal. I've had people before that try to multiply these two together and get 5.
No, it's attached.
That's
One of them has an exponent and the other one doesn't, which means you cannot multiply those together.
Divide by
Do not
10.
do that. We have to divide the 10 over.
so 1.
Okay. 1/10 is 0.1 if you want to do that as a decimal. 0.1 equals 0.5 to the T over 1590. Okay, now what do? I have to get that T
Log.
down. You can either log or you can ln. It doesn't matter. If you want to do ln just like we did the last one, you can do ln. That's fine. Log or ln will work the same. So this is, let's do ln. But the problem is ln doesn't cancel the 0.5, which is fine. It's okay.
It's
Okay.
But then we can move the thing out. Down.
But when we do that, we can move this junk in the front. Okay, I'm gonna write out all my steps. Okay, that's the rule with logs, is that we can move it down in front. So I have ln of 0.1 equals
T over.
T over 1590 times ln of 0.5.
Wait.
Okay, I just moved it down in front. I'm just moving it down in front. Okay,
okay.
now what can we do?
Divide by ln.
Get that ln out.
Divide by ln of 0.5. Okay, divide by ln of 0.5. Okay, now do that real quick.
1.1.
T over 1590 equals ln of that divided by ln of that. Make sure you close your parentheses on the top.
3.32.
3.32. Okay, and then to solve for T, times 1590. So it has split in half 3.32 times. So it's been quite some time, right? Like almost
5278.
5,000 years.
No.
5,000.
5279.
52818.
Yeah, no, Grace, you're wrong.
Did you use the full decimal?
Yeah.
Yeah. So 5.52
Why I didn't.
what?
5281.9.
9.
Okay, 5.82.9 years. You got 5.1 what?
Got 5278.
Okay, that's because you used 3.32 and they used, like, they just took the answer times 1590. Does that make sense? So they used a bunch more decimal places. So when you do this in your calculator, just take that answer times the 1590 and then it will be really accurate. Okay? So it's split in half for a while. Like 10 grams to decay to 1 gram. If you're just thinking logically in your brain about this, right? 10 grams split in half becomes 5. Split in half becomes 2.5. Split in half becomes 1.25. It is split in half at least 3 times, right?
That's dope.
Does that make sense? It's split in half at least 3 times. 3.32 times is how many times it is split in half. Does that make sense? To go from 10 to 1. All right. Next. Solve this by using properties of logs. So we have log of 4x equals 2. Now every log has a base. What's the base of this one? 10, because it doesn't have a number, so we assume that it is 10. Okay? Now we're trying to solve for x, but the x is trapped inside the log.
Oh,
Probably
do
get it out.
rearrange.
Let's make it an exponential function, okay? To make it an exponential function, we flip it around. We just did one that we flipped back, right?
2.
10 to the second power equals
So 100
4x, and then this is just easy, right? 10 squared is 100, and then divide by 4. What's 100 divided by 4? 25. Was that confusing? No, not too bad. Okay, just make it an exponential function and you can solve. Okay?
Moving on.
All right, good?
Yeah,
All right, we gotta get going because we're only 8 in. Okay?
That is a good.
We have 40 questions.
We
And some people are gone for track tomorrow. Woo! Okay? All right, these should go a little bit faster. 9. We already solved one of these. E to the 3x equals 7. I want to get the x out of there, but there's an e.
ln 7.
ln to get rid of each side, right? So ln and e cancel out. So on the left, I have 3x equals ln of 7. It doesn't cancel on the right side, but it cancels on the left, right? Okay, and then what to solve for x?
Divide.
Divide by 3. Divide by 3. So take ln of 7, close your parentheses after the 7, if you do it all at one shot, and divide by 3. And that is something.
0.648.
Point
649.
649. 0.649. Now, suppose I look at that and I'm like, I don't know if that's the right answer. What could you do?
Plug it in.
Plug it in. Like, it's really easy. Take e to the 3 times 0.649. You probably won't get 7 exactly, but you'll get something close to it because we rounded that number, right?
Right.
Okay? So you can check your answer. It doesn't take very long at all. All right? Number 10. They have 2 ln's, this one here and this one here, and what's in between them?
A minus.
Minus, and they want you to combine them
Divide.
together. Minus means
Divide.
divide, okay?
Move the 2 to
So
back.
the first thing we have to do, Mallory said, is move the 2 to the back. Did you remember that rule? This 2
No.
goes back here as an exponent,
Make a
right?
big
That's the
ln.
rule, okay? All right, now we have 1 ln, and we have a bunch of junk behind it. This is a single log,
X
right?
minus
Single
3
logarithm.
squared over 4x.
Okay, we're dividing.
What are you doing?
What is you doing?
Minus means divide, so we're putting all together into one log, 1 ln, right?
Okay.
On the top goes x minus 3 squared. On the bottom goes
4x.
4x,
Why did you get a squared?
because we moved the 2 to the back.
Are you dumb?
She
You
moved.
moved it. The 2 on
The
that
2
one.
the 2 in the front of the ln can move to the back of that one. All right? Make sense?
Is that
Good,
the
good.
answer?
That's it. That's all we're going to do for that. Okay? All right? All right, now we're getting to the nice stuff. Changing degree to radians to degrees, degrees to radians. What's the conversion?
Something about something pi over 180.
Pi over 180 or 180 over pi? Which one do you want to use for this one?
It's 180 over pi.
180 over pi, because we want the pi's to cancel. Okay, and then we reduce. What else reduces?
180 and
2 and 180 becomes 1 and 90. So I have 5 times 90 over 1, or just 5 times 90.
450
450
degrees.
degrees. Okay, what happens if there was a negative in front of that 5 pi over 2?
Make it negative.
Add the negative to your answer. That's all. It doesn't change anything.
Change.
Okay?
Okay.
All right, next.
Whoa, whoa,
No,
whoa,
no,
whoa,
no,
whoa,
girl,
whoa.
you're going too fast.
All right, ready? Okay, 240 degrees to radians. We make that into a fraction first. I always put it over 1. Times, this one's
Pi
conversion
over
is
180.
pi on the top, 180 on the bottom. Okay, and then we reduce, right? You do not give me any decimals. No decimals for this problem. No decimals for this problem. I know for sure I can cancel a 0, right? What about 24 and 18? What else can reduce?
3
6.
and 4.
6, if I divide by 6, 24 divided by 6 is 4, 18 divided by 6 is 3, so this is
4 pi over 3.
4 pi over 3. By the way, you can use your unit circle on this. So 240 degrees is literally on your unit circle.
Whoa, whoa.
It's 4 pi over 3.
Legendary. I'm gonna put
Now, just keep in mind that the one that I give you, like 240, like I might give you like 110 degrees, which is not on your unit circle. So you wouldn't be able to check it then, but
If possible.
if possible, yeah. Okay, good.
Because you're dumb. Because I'm so.
Okay, next.
Give the angle measure represented by 2 rotations clockwise.
720.
No, wrong.
Clockwise. so
Clock?
it's
I'm being
negative.
very picky.
Oh, negative 720.
Yeah, so we always start here, and if we're going 2 rotations, that's 1, that's 360.
I'm confused.
2 rotations, but we're going clockwise, which means we're going
Negative.
down, which means we're going negative. So if you're going 2 rotations, 1 rotation is 360 degrees. 1 rotation. They might also call this a revolution. 1 rotation or 1 revolution equals 360 degrees. But we are going clockwise, and we're going 2 of those. So I'm just going to put negative 720 degrees. Does that make sense?
So if it's going counterclockwise.
If it was going counterclockwise, it would be positive. What if I said like 5.5 rotations?
I don't know. I wouldn't do it.
5.5 counterclockwise or clockwise?
360 times 5.5. And then clockwise is negative.
0.
Counterclockwise is negative. Yeah.
14.
Yeah? Does that make sense? Any questions about this problem?
No.
Okay. Identify one positive one and negative angle.
Plus
Coterminal.
360
Oh.
Minus 360.
11 degrees is this angle right here. Actually, it's like smaller than that. But anyway. So if I go 1 more rotation around or 1 less rotation around, I add and subtract 360, right? 11 plus 360. So 371 degrees would be the same as 11, right? What else?
Negative
chill out for a second?
349.
Negative. Whatever you said.
Negative 349.
Negative 349 degrees. Those all will be the same position.
I might ask. Okay. Wait, I have a question.
How were you confused, Rachel? It's so
I have a question, Mrs. K.
Yes.
If
I know, and she's going so
you have,
so
what if you
fast.
have an angle where subtracting 360
Oh, I
doesn't make it
remember.
negative? It's
Okay,
just
I'm going to give you an
minus.
example.
No, is that still a negative angle or no?
No, it's not.
So you have to keep
So like, let's say I have 400 degrees, right? If I add 360, that's great. That's 760 degrees, right?
Yeah.
But if I take 400 and I subtract 360, that's 40 degrees. I have 2 positives. I don't have a negative yet. So I have to take that 40 and I have to subtract 360 again to make negative 320. So
Great.
sometimes you might have to subtract twice. And if that's the case, you could use 40 as your positive one and negative 320 as your negative one, rather than using 760 as your positive. Does that
Okay.
make sense?
Yeah, that.
So there's multiple answers that you can have, just as long as they're the correct, like
Makes
whatever,
sense.
right?
Yep.
Okay, good, very good question. Okay, that would be the same case with negative 400. It's just you would have to add 360 twice,
Okay.
right? Okay,
So I can just add a bunch of them and make it a really
Sure.
super giant number.
Sure.
Great.
great.
That takes time.
Okay, and then I'll just hate you checking
Or-
this,
yeah.
whatever.
That would be fun.
Anyway.
We can do that.
Find the measure of the reference angle. Circle the word reference angle.
No.
Doo-doo-doo.
40 plus Thursday.
Reference angle, okay?
What color equals
Where will 227 live?
They're like blue.
227.
Red is science.
Clayton says third.
No,
Green.
green. is history. Green
Green
is
is
history.
history.
Green is history. Red is like, no, it's like
English.
Okay,
yellow?
shh, we're almost done. What time do we get out? 26? Okay, we got like
One more. Wait,
8
did
minutes.
we already do that one? I didn't do
15.
that.
Okay, fine. No, I'm doing it right now. The reference angle, 227 degrees, is in the third quadrant. Okay, do you have your quadrants labeled? Like you know them, 90 degrees, 180 degrees. What's the bottom one? 270, and then 360, or 0, because 0 degrees is
360. Coterminal.
coterminal with 360, right? 0 and 360 are the same. Okay, so 227 will be in the third quadrant, but when I ask for the reference angle, do you know what I'm asking for?
She wants the
other
angle to
side.
270.
I want the bow tie angle, right? If I make it into a triangle, you always connect it back to the x-axis. We make bow ties, not hourglasses. I want this angle right here.
My pencil's.
So in the third quadrant, 227 is past 180 degrees. I know that 180 is from here to here, right? So how much more?
You subtract
227 minus 180, And that's 47 degrees is the reference angle. Okay? Yeah?
Got it. Okay, let's be done now.
Okay.
Paid attention really good today.
Can we
Now,
finish this page?
one more thing real quick. Let's say that we
I
had,
agree. The less
you don't have to write this down, but let's say that we had like negative, let's say we had negative 190 degrees, right? What quadrant would negative 190 be?
3.
Yeah, I'd be in 3. Yes,
Negative.
4.
Oh,
Or
Ne-
2.
2.
This is negative 90, 180, 190 would be right here. What would the reference angle for that one be?
10.
Is it 10 or negative 10?
Negative. No, it's just 10.
It's just 10. Reference angles are only positive. So 10 degrees. Does that make sense? So even if I give you a negative angle, your reference angle will be positive. If you want to write that down, you can, but you don't have to. Okay? Make sense? Good, good. Okay. Shall we do 16, 17, and we'll quit? Okay. Sine, cosine, and tangent. Okay. And we're doing for angle A. So sine of A, cosine of A, tangent of A. And we're just looking for the fraction stuff, right? Okay. I have this triangle labeled, and the reason why I'm able to use sine, cosine, and tangent is because it's a right triangle, right? Like I have this little box in the corner that's kind of half cut off, right? So, yes. So write in SOHCAHTOA if you need to. Okay, we're just doing the fractiony things. All right. First things first, we need to find.
Sine.
No, you
Uh-uh.
angle.
We need to find the hypotenuse side, right? This is the hypotenuse. That's C, right? Okay. So like this is A, B, C.
60 squared. Second square root of the answer is 100.
6,400 plus 3,600 equals C squared. This is like 100,000. No, 10,000. You're right. Have too many zeros. Okay. Equals C squared, and I take the square root. Okay. But also, this is
You can take off one of the zeros from each of them.
right. So when we do sine, cosine, and tangent, you need to have them reduced. Yeah.
Redo.
So let's reduce them over here before we put them in the fractions, right? So I know that I can cross off a 0. What else can I do?
Divide by 2.
Divide by 2. So this is a 4. This is a 3. This is it's a 3, 4, 5 right triangle, right?
3 over 4.
Which angle are we looking at?
A.
A. So circle A. Which one is opposite?
3.
3. Hypotenuse?
5.
Always 5. And the adjacent is 4. So sine is OH.
3 over 5.
3 over 5. We're just doing the thing, right? Cosine? 4 over 5. Tangent?
3 over 4.
3 over 4.
You know, I love this.
Yeah. Okay.
Okay.
All right. 17. 17. There's a lots of stuff going on in 17, but it's pretty well similar to what we just got done doing. So 17. Here you go. There are 3 pieces of information. The first thing it gives you is that sine is this. Save that for later. We're going to start here. This is where we're going to start at. Okay? And this is where we're going to end with.
I know I'm not going to be doing that.
No.
Okay? So, starting with that middle piece, if they say theta lives from pi over 2 to pi, what does that tell me?
It lives in the first quadrant.
I'm saying you don't know. You're gonna do your
Where's pi over 2?
Pi over 2 is straight up.
Pi over 2 is straight up. Where's pi?
Oh, pi over yonder. It lives in the second
So,
quadrant.
we have a triangle. If it says theta lives over here, right, in between those two. So, we have a triangle in the second quadrant. We're going to make it. Like that. Here's where theta lives. This middle piece just tells me what quadrant we're in. We're in the second quadrant, right?
Yeah.
Okay?
And 1 is the opposite,
right.
3 is the hypotenuse.
So, are we good so far? The starting information, done with that, right? Now we're going to move on to sine of theta. So, sine is SOH. And O is 1 and H is 3. So, we're just going to label our triangle. O is opposite 1 and H is 3. Okay?
Square root of
Then
10.
we've got to find this side right here. They're not square root of 10. Okay? Which side is your side C?
Oh.
3, right? So we have 1 squared plus x squared, right? 1 squared is 1. 3 squared is 9.
1 plus 8.
So we're going to subtract the 1. X squared equals
Square root of 8.
8. And so we have the square root of 8.
Ooh, that's ugly.
Yeah. Just leave it as the square root of 8. Don't give me a decimal. Don't give me a decimal.
Cotangent, you find tangent and flip it.
Okay, am I going too fast? Are we okay?
No, you're good. No.
Now we're doing cotangent. That's what we're ending with. So we need cotangent of theta. Now tangent is TOA.
Over- It's the square root
So-
of 8 over 1.
Cotangent is A over O, right? That make sense? If cotangent is OA, then if tangent is OA, then cotangent is AO. AO is going to be square root of 8 over 1, or just the square root of 8. You can leave it like that, right? Okay? All right. Okay? Good?
Good.
All right, for you track people, I'll record the second chunk tomorrow and send it to you. On Friday, I will be gone. Somebody needs to pull the thing up on my computer. Yeah?
Yeah.
Okay. All right, goodbye people watching this video.